You are told that this is a sequence of negative numbers. Negative numbers, huh? Okay, firstly, since xn, right? All these are negative numbers, okay? Negative numbers. Xn has to be less than 0. This is the first one. Okay? Xn has to be less than 0. And because due to the way you describe a sequence is you multiply 3 by the current term, then add 8, and then you root the entire thing, then you apply a negative. Okay? So essentially what I'm trying to say is that this guy inside here, okay, have to be positive. Agree? You cannot square a negative number. You only square a positive number, right? Okay, not until you get to complex lah, but this case here, you're told that they are negative numbers, negative real numbers to be exact lah. But negative real numbers is just the same thing as so and 8 plus 3xn has to be positive. Okay, positive. Can it be equal to 0? Or it cannot be 0. Once it's 0, then it's no longer negative. Okay. Your square root 0 is 0 ma. 0 is no, so you cannot let this be 0. You have to be positive. So xn is negative 8, then xn is bigger than 8 over 3. So you need to satisfy both of this on the number line. So hence, sorry. This means that each term, as n goes to super big, all the terms will converge to. So essentially, part 2, n goes to infinity, xn goes to L, xn plus 1 goes to L as well. Then, so from xn plus 1 minus 8 plus this recurrence relation here will just tend to L equals to minus 8 plus 3L. Okay, then this will be L square. Then L square minus 3L plus 8 equals 0. Okay, so it has to be 3 minus root 41, not the positive one, because it's a negative real number for the sequence. So L is negative. Actually, you want to show that xn plus 1 square minus L square is equals to 3xn minus L. So you know that this will just square the entire thing here. N plus 1 equals to minus 8. Okay. That will be 8 plus 3xn. So there's another way, which is from here, you know that L square is equals to 3L plus 8. You can just replace it in. This is easier. Okay, but you can also do by replacing the value in and manipulate the certs. So show algebraically if x at okay, it's always the same trick. For some value of n, then xn plus 1 is bigger. It's the same thing, the question that we did just now, part 4. So xn given that less than L for some value of n. So xn minus L is 0. So you can obviously multiply by 3, positive 3 both sides. Then you just sub. Then you know that from part 3, 3xn minus L is equals to xn plus 1 square minus L square. So this guy will be xn plus 1 square minus L square. I use difference in squares. Okay. This one is positive or negative? This one here? This one? Xn plus 1 plus L is no longer positive. This is negative, right? Correct or not? This is negative. This is negative. Overall is positive or negative? Overall is negative. Overall is negative because, okay, so in other words, since xm plus 1 plus L is negative, this will suggest that xm plus 1 minus L is positive. Okay, because positive times negative gives you overall negative. So hence xm plus 1 is bigger than L. Okay, so this is it. You replace it in, you do a algebraic factorization. So since this guy is negative, so this will tell you that this guy multiply this guy overall is negative, right? This guy is positive. Then you will get this.